Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and let's try to solve it together. So at first of all, let us try to understand the problem statement because that's the most important thing. So we have this Pacific Atlantic water flow problem where there is an M cross N rectangular island that borders both the Pacific Ocean and the Atlantic Ocean, and in this island it is given each cell represents the height of that particular region. Okay, so I comma j region, it just represents that particular height, what is the height of that region. Okay, and you can see that as shown in this example, the top and left portion are surrounded by Pacific Ocean and the bottom and the right portion are surrounded by the Atlantic Ocean. Okay, and you see when it rains on this island, it is told that water can flow from this island to the Pacific Ocean only if there is a certain arrangement in terrains. Okay, so let's say if if it rains and it falls on this grid, let's say this portion where there is written 5 in the middlemost. Okay, you focus on this and you see till what, how can water seep. Okay, the water can only seep from a higher region to a lower region. So you see 5 is higher than 3, so it can, water can seep from 5 to 3 and it can go from 3 to 1 and then it can go to the ocean. So you see from 5 you can reach the Atlantic Ocean, and from 5 you see you can also reach the Pacific Ocean in various ways, from 5 4 2 also, 5 3 2 also. In many ways you can reach the Pacific and the Atlantic Ocean only if the terrains are less than or equal to. Okay, so it means that from a higher region to an equal or a lower region the water can flow, so it makes sense also. So yeah, you need to find how many such blocks, how many are there such blocks that that can flow to both Pacific and Atlantic Ocean. So for this example of 5, you saw that it can flow to both Pacific and Atlantic Ocean, and for this 5 you see it can already directly flow to Pacific and Atlantic. If you see top of this 4, it can flow to Atlantic Ocean directly, and for Pacific Ocean it can go to this 4 and then this 3 and then go ahead. Okay, so you need to return all the cells. You need to return a vector of vectors, so it will be a vector of coordinates. Those coordinates will be the cells from which you can reach both the Pacific and the Atlantic Ocean. And yeah, that is all meant by this problem, and I hope you at least understood the problem statement. Okay, there should be no doubt regarding the problem statement at first. Okay, so yeah, that was all. Now if you initially did not understand what we need to do in this problem, you can just go ahead and try on your own. You can just pause this video. Okay, so yeah, for the solution, let's continue. Okay, so the thing which you observe in this problem is that the flow of water. How can we reach the flow of water? Okay, now one thing is very obvious is that let me draw the island first. Okay, let's say this is your rectangular island, and here there is Pacific Ocean, here there is Pacific Ocean. Okay, I will draw it in blue, and here there is Atlantic Ocean to the bottom and to the right. Okay, so what will happen, you can easily see for these many cells, for all the cells in the first row, it can directly flow into the Pacific Ocean. It can directly flow into the Pacific Ocean. Okay, this is very obvious. Okay, now you see for this whole column, it can also directly flow into the Pacific Ocean. Okay, now you see let's say the height of this is 2 and the height of this is 3, and you find something, somewhere that height of this neighboring region of 3 is, let's say, 1. What can you say now? You can say easily that water can flow if it rains on 1. Water cannot, I mean, it cannot flow to 3 because 3 is greater than 1. It can flow from 3 to 1 but not from 1 to 3, right? So it cannot flow to the Pacific Ocean. You can say it something like this. But you can also tell me that if, what if this instead of this 1 there was 5. You can see 5 is greater than 3, and definitely to the neighboring region of 3 you got something which is greater than 3, right? So what you can do, you can say that if it rains on this 5, it can flow to 3, and from 3 it can flow to the Pacific Ocean. Okay, so you can see that if I try to tell you that let's say I am marking with blue tick whichever is flowing into the Pacific Ocean. Okay, so these all cells can flow to the Pacific Ocean directly. Okay, now you see I told that 3 can flow and also 5 can flow. Okay, now you see if there exists some other cell, let's say 7 to near of 5 and let's say 9 here also, you can see very easily and obviously that from if this water rains on this 7, it can flows to 5, 5 can flow to 3, 3 can flow to Pacific Ocean. Okay, and also if it flows on 9, it can flows to 7 and 7 can take it away to the Pacific Ocean. So you can definitely understand one thing, you can, I hope you are starting to understand few things right now, is that we can start from the boundaries and mark a visited array by the Pacific Ocean. So let's say I will keep a visited array whose, let's say, visited I comma j will tell me whether the cell I and j is visited by the Pacific Ocean or not. I will mark it 0 or 1 accordingly. Okay, I will keep another vector visited Atlantic, okay, which will tell me for I and j, which will tell me that whether a particular cell is being visited by the Atlantic Ocean or not, and that will be very similar to the Pacific Ocean. It will follow the exact same rules, so we can simply write a function. Now what inside that function we need to populate this, our main aim will be to populate these visited arrays of Pacific and Atlantic Ocean, and at the end I can simply loop through all of these cells. Okay, for all I, okay, so for all, let's say for all I will have a loop, and then for all j I will have a loop, and I will say that if my I comma j cell is visited by both this Atlantic Ocean as well as this Pacific Ocean, you can add this I comma j pair into my answer. You can just add this into my answer, where answer will be something outside this loop, and you can simply return answer. Okay, so yeah, I hope that much is very much trivial and easy to understand. Now how exactly should I write and populate this visited array? Now if you try to understand, okay, from a particular cell, where can the water reach? How can I tell that what can be the extent of the reach of the water? So if I try to figure that out, if I try to figure that thing out, let's consider this cell of 5. You see, from 5 water can go to this cell, this cell, and to this cell also. Okay, so but it since I am starting my traversal from the boundary points, I can go from 5, so I will definitely not go to 3 again, because so I will just keep this visited array itself will help me not to go back to 3. Okay, oh, so you understand one thing again, right? Once you go back to 7, you also have your neighboring cells. So at every point, you are exploring neighboring cells. You are exploring all the neighboring cells. All the neighboring cells. Okay. So this definitely gives you the idea of BFS. Okay. This definitely gives you the idea of BFS. So if you do not know what is breadth for search, it is used to find one shortest path from a source to destination. But how does it find? It just explores through all the cells, and for every cell it explores all of its surroundings and tries to find this D until it reaches D. Okay, and then it tracks to find whichever is the shortest path, and it is implemented using a queue. If you don't know the implementation, so see, some prerequisite I do need to assume. At least you know the BFS. This much I will assume. Okay, if you do not know, you can just quickly search from Gigs for Gigs, or you can stay till in the video also. Okay, so for this source, you see, you are finding the destination, but for this problem we are using it for different purposes, only to see which cells are reachable. Okay, and here is only one source in BFS, but this is a multi-source BFS. These are all my source which I need to push in the queue initially. Okay, yeah, so that's how I will implement this BFS. I will simply push all of these elements into my BFS and tell that those are visited by the Pacific Ocean, and you keep exploring. Each of the cell will keep exploring all its neighbors, and if it finds that the height is suitable, if it finds that yeah, the height is exactly suitable, it will simply push elements more into the queue and extend the BFS search, and also push and also mark this visited array. And at the end we will also do a same thing with the Atlantic ones. We will push these elements in the Atlantic Ocean, and finally we will check that using these visited arrays, we will check that which are those coordinates which are both visited by the Pacific Ocean as well as the Atlantic Ocean, and I will simply add that to my answer. Okay, so I hope this approach is at least very clear to you. As we will do the coding portion, things will become more clear and very easy to understand basically. Okay, so what will I do at first? I can have the row and column numbered. Okay, so I will do height dot size m. I will definitely do height of 0 dot size. Okay, for m and n I just did that. And yeah, uh, what else do I need? I definitely need my visited arrays. Okay, so let's say that will be definitely vector of vectors, and it will be, let's say, visited Pacific Ocean. I have m rows and n columns. Initially I will mark all of them with 0, and I will do the same thing for the Atlantic Ocean also. I will have a vector which will tell me the visited cells by the Atlantic Ocean. Now what should I do is very simple actually. I should go through this, let's say, one by one. I will fill the column, I will fill the rows and stuffs like that. Okay, so yeah, I will also have a queue which will contain coordinates, right? So let me have pair for that, and yeah, I have this queue with me. Let's say I have two queues, q1 and q2. Q1 is for the Pacific Ocean and q2 is for the Atlantic Ocean. So yeah, so what can I do at first is that uh, I am inserting this first column at first. Okay, so this first column will be visited by the Pacific Ocean and will go to q1. Okay, okay, so what will happen is that I will do visited by the Pacific Ocean I comma 0. This is the ith row, and the 0th column, the first column which I am talking about, and I will mark this as 1 because it is visited by the Pacific Ocean. And I will also do q1 dot push, q1 dot push this coordinate. Okay, I will since I need to start this BFS from this point, I need to also push elements into my queue. It will be a multi-source kind of BFS. So yeah, we have these things. I need 4 such loops, right? I hope you can easily understand why I need that, because 2 will be for Pacific, 2 will be for Atlantic, and definitely these elements will be J. Okay, so just for symbolic purposes I will write them to be J. Yeah, and these m will be n. It's quite obvious because we are iterating through the other dimension. And for this Atlantic Ocean you need q2 to push into. Okay, and for this you can also observe some things, is that this will be uh, for J. Okay, for J, when you are doing you for the Pacific Ocean of J, you see you have the first row which is 0, and the second column will be iterated by this J variable. Okay, so 0 comma J is what you need to insert. Okay, I hope that is clear. And for the Atlantic Ocean, you see it's the last row and the last column. Okay, so for the last column I have this I comma n minus 1. Okay, I have this I comma n minus 1. So these are the coordinates of the cells. I hope there is actually no confusion uh, regarding these things. You can do these on your own also. This is not at all difficult. So I am just pushed all the boundary elements. Okay, so I am just pushing all boundary elements into respective queues, for BFS, and marking as visited. Okay, so yeah, that's what I did. Now I will write a simple BFS function, okay, which will simply take this height. It will take this heights, and you see this is not height, this will be heights. And what will it take is that it will definitely take this visited Pacific Ocean with Q1Q, and definitely it will also take the visited Atlantic Ocean with this Q2Q. Okay, so that will happen. Okay, so search for BFF, search for neighboring cells. So what it does is that search for neighboring cells and fill the visited arrays. Okay, now I will simply go through all the cells. It is, I will write the BFS function later. I will just, yeah, I will just do this first. I have an answer also with me. Vector of vector will be my answer, right? So yeah, I do have it, and for this I also have. Okay, so I do not need anything because this will be a vector of coordinates only. So what will happen is that for I and j, I will go through all the coordinates. Okay, for all the coordinates, now you see what can happen is that I will tell that if it is visited by the Pacific Ocean, this I comma j coordinate is visited by the Pacific Ocean if it is 1, and if it is visited by the Atlantic Ocean also, then what you can do, you can just simply do answer dot push back, because that is my current cell which can actually flow all the rainwater to both of these oceans, and I can simply push that back into my answer and return it. Okay, return answer. So yeah, that will be it, but I need to definitely write this BFS function. And for BFS on grid, you need to know that we do something like this. If we are starting from one point, we can go to 4 directions. I have explained this to you many times in my videos. If it is ij, uh, it will go to something, if it goes here, it will be something like ij plus 1, here it will be ij minus 1, here it will be something like I plus 1j, here it will be something like I minus 1j. Okay, so that's what. And if you see, if you try to uh, analyze how exactly we are traversing, you see we are adding few numbers to our I and j. Okay, I and j, we are adding few numbers. This is 0 and minus 1, we are adding to both I and j. Here we are adding 0 1, here we are adding 1 0, here we are adding minus 1 0. So these are the direction vectors which we are adding into my initial cell to go to those specific direction. Okay, so for traversal of from one cell to another, we need a direction vector. Okay, so it will be nothing but vector of vector. We have this 0 1 1 0, we also have minus 1 0, we also have 0 minus 1, and this will be my direction vector. I will have a simple void BFS function which will take this heights element. Okay, okay, so this first argument is definitely this heights, the second argument is definitely this visited, and the third argument is nothing but q of pairs. Okay, pair of. So yeah, you can just simply have this q added. Okay, so yeah, you do have this BFS function with you right now, and what you can do, you can just copy this line. You need m and n here, and yeah, I will do simple q traversal using BFS. So while q dot empty, I will keep finding the neighboring cells of this q. Okay, so first I need the elements of q. So for my x and y elements will be something like q dot front, and since it is a pair, we can access it by using the first and second variables. Okay, so first and second argument. So this is first, and for second also I can just go through this q dot front, and we can have this second with me. Okay, so I hope this is clear to you. There is no difficulty in this, and I can do q dot pop also simply. And so for every cell I need to see which are my neighboring cells, right? And how many neighbors are possible? There are 4 neighbors along these 4 direction vectors, right? So I can explore 4 neighbors through these 4 direction vectors, and they will be nothing but, instead of x and y, I will call them x1 y1. Okay, I will simply call them x1 y1, and what will they be? X plus you add this direction vector, okay, 0 for the x coordinate of the direction vector and 1 for the y coordinate. So you got the new cells which are nothing but the neighboring cells of this x and y, and these are nothing but the neighboring cells, right? Now you need to assure few things, okay, whether these neighbors are lying within the grid or not and stuffs like that. So if for these neighbors to lie within the grid, what you need to do is that x1 will be less than m and y1 should has to be greater than 0 and y1 need to be less than n. These are the criteria which will determine that x1 and y1, these are not going outside the grid, because that is the most preliminary thing. And I need to see that if it is not visited, this x1 and y1 should not also be visited previously, and the height should also allow the flow of water, right? So from x to y, as I am going x1 y1, I am going from boundary to inside, okay, so I need increase in height. So heights of xy, that should be less than equals to heights of x1 y1. Okay, so I hope you do understand what I'm trying to say. We are moving from xy was on the boundary point initially, and we are moving inwards and exploring all the neighbors, and as we are moving inward, so the inward height should be more, this inward height should be more than or equal to this from this height, okay. Then only what we can tell if all these criteria hold true, that is the neighboring cell has valid coordinates, the neighboring cell is not visited earlier, the neighboring cell allows the flow of water. If all of these criteria holds true, then only you can say that I am eligible to push into my queue in this neighboring cell and explore further. I can say that the water will go into this cell. Okay, water will definitely have into this cell. So what can I tell is that q dot push, I will push simply x1 y1, and I will also mark this x1 y1 as visited. Okay, since I have already visited this, I will simply mark this also as visited, and if you try to see, that will be all unless I did some errors. So let's try to run and check if it works or not. I hope there will be no issues. I just need to pass this by reference, and yeah, for during the BFS call, maybe I did some error here. I have visited Pacific and Atlantic. If I try to run this, you see we did get the accepted thing, and there was no error at all in my code. So I hope you do understand the approach, and if I try to submit this, you see we also do get a very decent runtime complexity, 79.76. If it allows me to analyze, you will see that we have a simple m into n time complexity. Yeah, so that's all I will say for this video. This was mostly an implementation based problem. If you have practiced some graph problems already earlier, this problem will not be at all difficult to you, at least intuitively, and the implementation, as you do more and more problems, you will definitely learn this. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.